Welcome to Level 1 Mechanics, Speed Time Graphs. Speed time graph is a visual way of displaying motion. The vertical axes of a speed time graph will always be speed, while the horizontal axes will always be time. Okay, if you get those mixed up, it's not good. A straight line on a speed time graph indicates constant acceleration. Okay, so there's no change there's no change in acceleration. The gradient or steepness of a straight line on a speed time graph will tell you the acceleration of an object. So here we have a couple of axes, speed and time. If we draw a line on there, you can see it's a straight line, so it's constant acceleration. The gradient is very small, so we have low acceleration. If we draw another line, and you can see this one is very steep, it's still straight, so you get constant acceleration, but because it's so steep, it's got a large gradient, and as a result, that shows you there's a large acceleration. So it's speeding up very fast. Alright, if we take a look at another one, if we've got a horizontal line, this tells us that speed is not changing. So, what does that mean? You got it. No acceleration. Zero acceleration. Next, if we have these two axes again, and we have a line that follows this pattern, it's still straight, so there's constant acceleration, but there's a I don't know what you call it, a downward trend, shall we say, and that's a negative gradient, which tells us there's deceleration or negative acceleration, or our object is slowing down. The gradient of a speed time graph is the same as the acceleration of an object. Gradient equals rise over run. Okay, we've done this before in the distance time graph video. So we've got this speed time graph here, and again, you notice this is a speed time graph. Make sure you read those axes so you know exactly what you're dealing with. So if gradient equals speed, then we can say gradient is rise over run, rise divided by run, and what we need to do is draw a triangle, a right angled triangle below our line, as I've drawn there. And from that, you can see our rise, and there's our run. The rise is 25, okay, because it goes from 10, right here, all the way up to 35. 35 minus 10 is 25, so it's the difference between those two. So it rises 25. The run starts at 0 and finishes at 90, so that means our run is 90. So we take those numbers and put them into our equation. 25 divided by 90, rise over run. We get a gradient of 0.277777777, and so on. As I said before, in Level 1 Science, round off the 2 decimal places and you won't get it wrong. Okay? Or you can also look at these. You've got 2 significant figures, 2 significant figures. So your answer should have 2 significant figures. So in this case, we can round it to 0.28 meters per second squared. So that's our acceleration. And that's it. Welcome to the end of this video, and that's how you do it.